For decades, humans have dreamed of reaching Mars. The red planet has always been a symbol of mystery and the next frontier for human exploration. From ancient astronomers who first observed its reddish hue in the night sky, to modern scientists who have sent robotic explorers to its surface, Mars has been a constant source of fascination. It's a planet that has captured our imaginations and sparked our curiosity. The barren landscapes, the towering volcanoes, and the possibility of ancient life have all contributed to our enduring interest in Mars. Today, we stand on the cusp of making that dream a reality. With advancements in technology and a renewed commitment to space exploration, humanity is closer than ever to setting foot on Mars. The United States is leading the charge, pushing the boundaries of space exploration and seeking new ways to reach the red planet. NASA, along with private companies and international partners, is developing the technology and strategies needed for a successful mission. This time, we're not just aiming to visit, we're aiming to stay. Establishing a permanent human presence on Mars will require innovative solutions for living, working, and thriving in an environment vastly different from Earth. To achieve this ambitious goal, we need to overcome a significant hurdle distance. Mars is not only far away, but the journey also presents numerous challenges, from prolonged exposure to space radiation to the psychological effects of long-duration missions. Mars is much farther away than the Moon, our closest celestial neighbor. While the Moon is about 238,855 miles from Earth, Mars can be over 140 million miles away, depending on its position in its orbit. Getting there quickly and safely requires a new approach to space travel. Traditional chemical rockets are not sufficient for the long journey to Mars, necessitating the development of more advanced propulsion systems. This is where nuclear propulsion comes in, a game-changing technology with the potential to revolutionize space exploration. By providing greater efficiency and faster travel times, nuclear propulsion could be the key to unlocking the mysteries of Mars and beyond. Currently, we rely on chemical rockets to launch spacecraft into space. These rockets have been the backbone of space exploration since the mid-20th century, enabling us to reach the Moon, deploy satellites, and build the International Space Station. These rockets use chemical reactions to create thrust, propelling the spacecraft forward. The process involves burning propellants, which produce hot gases that are expelled at high speed to generate the necessary force. While this technology has served us well, it has limitations. The efficiency of chemical rockets is constrained by the energy density of the propellants they use. Chemical rockets require a lot of fuel, making them heavy and expensive to launch. The sheer volume of fuel needed adds significant weight, which in turn requires even more fuel to lift off. They also have limited speed, which means longer travel times for astronauts. This slow pace is a major drawback for missions beyond Earth's orbit. A trip to Mars using conventional chemical rockets would take about 6 to 9 months. This extended duration poses significant challenges for human space travel. That's a long time to be in space, exposed to radiation and the psychological challenges of confinement. Prolonged exposure to cosmic radiation can increase the risk of cancer and other health issues. Nuclear propulsion offers a solution. By using nuclear reactions to heat a propellant, these engines can achieve much higher efficiencies than chemical rockets. It promises faster travel times, reduced fuel requirements, and increased payload capacity. This means we can carry more supplies and equipment, making long-duration missions more feasible. This makes it a game-changer for Mars missions and beyond. With nuclear propulsion, the dream of exploring deeper into our solar system becomes a tangible reality. Nuclear thermal propulsion, or NTP, harnesses the immense energy within atoms to propel spacecraft. This technology is a game-changer for space exploration, offering a new way to travel through the cosmos. By tapping into the power of nuclear reactions, we can achieve speeds and efficiencies that were previously unimaginable. Unlike chemical rockets which burn fuel, NTP systems heat a propellant, usually hydrogen, to extremely high temperatures using a nuclear reactor. The reactor's core generates intense heat through nuclear fission, a process where atomic nuclei split and release energy. This creates a powerful jet of hot gas that propels the spacecraft forward. The heated hydrogen expands rapidly and is expelled through a nozzle, producing thrust. This method of propulsion is not only powerful but also highly efficient. Imagine a pressure cooker, but instead of steam, it generates superheated gas for thrust. The concept is similar, but the scale and temperatures involved are far greater. This superheated gas provides the necessary force to move the spacecraft through the vacuum of space. This process is far more efficient than chemical combustion. Chemical rockets are limited by the energy density of their fuel, but nuclear rockets can achieve much higher efficiencies, making long-duration space missions more feasible. Nuclear fuel can produce up to 10,000 times more energy than an equivalent mass of chemical fuel. This incredible energy density means that spacecraft can carry less fuel and more payload, which is crucial for missions to distant planets. This means we can send larger payloads to Mars and beyond, using less fuel and reducing travel times significantly. The potential for faster and more efficient space travel opens up new possibilities for exploration and even colonization of other planets. One of the most significant advantages of nuclear propulsion is its speed. While a traditional chemical rocket might take over 6 months to reach Mars, a nuclear-powered spacecraft could potentially cut that time in half, reaching the red planet in as little as 3 months. This reduction in travel time has several benefits. First, it reduces the amount of time astronauts spend exposed to the harsh conditions of space, such as radiation and microgravity. This is crucial for their health and well-being. Second, it allows for more flexibility in mission planning and execution. Keeping astronauts safe and sound, the benefits of speed. The health and safety of astronauts are paramount in space exploration. Long-duration space travel poses several risks, including exposure to cosmic radiation, bone density loss, and muscle atrophy. Faster travel times offered by nuclear propulsion can mitigate these risks. By reducing the duration of spaceflight, we can minimize astronauts' exposure to harmful radiation and the physiological effects of prolonged microgravity. This means they arrive at Mars healthier and more prepared for their mission. More than just speed advantages of nuclear propulsion. Beyond speed, nuclear propulsion offers other advantages for space exploration. Its increased fuel efficiency allows for larger payloads, meaning we can send more equipment, supplies, and scientific instruments to Mars. Moreover, nuclear rockets provide greater maneuverability in space. They can make course corrections or even change their destination mid-flight, offering more flexibility and adaptability for future missions. Recognizing the potential of nuclear propulsion, NASA and the Defense Advanced Research Projects Agency, or DARPA, have teamed up. Their collaboration aims to design, develop, and test a nuclear thermal rocket engine for future space missions. This partnership combines NASA's expertise in space exploration with DARPA's experience in advanced technology development. NASA will focus on developing the nuclear thermal rocket engine itself, while DARPA will lead the development of the nuclear reactor that powers the engine. This division of labor leverages the unique strengths of each agency. The NASA-DARPA partnership plans to conduct ground tests of a nuclear thermal rocket engine by the early 2030s. These tests are crucial for proving the technology's viability and safety before its deployment in actual space missions. If successful, this technology could enable crewed missions to Mars as early as the late 2030s or early 2040s. It also opens up possibilities for exploring other destinations in our solar system, such as the moons of Jupiter and Saturn. Safety is paramount in developing and implementing nuclear propulsion technology. NASA and DARPA are committed to ensuring that these systems meet the highest safety standards. The nuclear reactor will be designed to prevent any accidental release of radioactive material, both during launch and throughout the mission. Furthermore, the engine will only be activated once the spacecraft is safely in space, far away from Earth's atmosphere. This minimizes any potential risks associated with launching a nuclear reactor from Earth. Nuclear propulsion holds immense promise for the future of space exploration. By enabling faster travel times, increased payload capacity, and greater mission flexibility, this technology has the potential to revolutionize how we explore the cosmos. As we push the boundaries of human ingenuity and venture farther into the universe, nuclear propulsion will be an essential tool, unlocking new possibilities for scientific discovery, human exploration, and our understanding of our place in the cosmos.